In this session, we are going to learn how to develop ARIMA model in SAS. These are the syntax for import Excel data into SAS program. So before doing this, you have to upload your Excel data into SAS. If you don't know how to do that, please go and check this video first. So this is a comment. Anything between slash and a star is ignored by SAS. Normally we use it to label section for viewers to better understand. Proc import start SAS import procedure. So data file point to the Excel file. So for this session, I use ARIMA data.xlsx as my Excel file. Go to your Excel file and click right, and then go to properties, and here you can see your file location, and copy that and paste into data file equal here, and always wrap the path in quotation mark. So out equal names the output SAS dataset. Here it will be created as work.mydata. So this is temporary. It will be disappear when the session ends. dbms equal tells us the file type to use. So Excel SX is used for modern Excel workbooks. If you have your data in CSV file, then you have to put CSV instead of XLSX. Replace. If a dataset with the same name already exists, overwrite it without asking. Handy during iterative development, so your import doesn't fail if my data is already there. And you have to put semicolon marks before, because our statement is end here. So next statement is sheet. So normally we use sheet to choose which worksheet to import. Because sometimes your data file have different number of sheets, you can select which one is considered to this analysis. If omitted, SAS usually import the first sheet. Change this name if your sheet has a different name. And make sure to end the statement with semicolon mark. Get names equal yes semicolon. Tells SAS to use the first row of the sheet as column name and start the data on the next row. So if your sheet doesn't have headers, set get names no. And SAS will create the variable name as A, B like this. And make sure to end the statement with semicolon mark. And the last statement for this procedure is run. You can use run to end the procedure. Always end with semicolon mark. Let's run the procedure to see the results. So what you have to do is highlight the codes that you want to run, and then click this running man icon. Here's our results. First step for ARIMA model is to check normality of our dataset. There are different methods to check normality. Here I use Anderson-Darling test to check normality. So, proc univariate run descriptive statistic and distribution analysis. Data equal my data tells SAS to use the dataset my data that we import earlier. The keyword normal requests formal normality test. It includes Shapiro-Wilk test, Anderson-Darling test, Kolmogorov-Shmirnov test, and Kramer test. Output will show test statistic and p-values. So, next statement is var impact semicolon. This specifies the variable to analyze. Here our variable is impact, and if you have different types of variable, you can add those variable into here. If you don't include var, SAS will analyze all numeric variable in the dataset. Histogram impact slash normal semicolon mark our next statement. The slash normal option overlay a fitted normal distribution curve on the histogram. It lets you visually compare data versus normal shape. Next statement is insert n mean std slash position equal ne semicolon mark. N means sample size, std mean standard deviation. It adds a box of summary stat on the histogram. So, position equal NE, place it in the northeast corner of the graph. So, next statement is QQ plot impact slash normal mu equal EST, sigma equal EST, close bracket and semicolon mark. This produces a QQ plot. QQ plot mean quantile plot. I think you already know what is QQ plot. So this plots the quantiles of your data versus theoretical normal distribution. Normal open bracket mu equal EST, sigma equal EST close bracket means estimate the mean and standard deviation. Means mu and standard deviation is sigma from your data instead of assuming fixed value. If point lies close to the diagonal line, that means the distribution is approximately normal. So our last statement is run apostrophe. Let's see what we can get from running this procedure. Once you run Anderson-Darling test, you will get this kind of results. Some tables and histogram and QQ plot. So, these are the main important things that we need. That is test for normality table and histogram and QQ plots. Let's see how to interpret these results. Test for normality gives us results of Shapiro-Wilk test, Kolmogorov-Shmirnovo test, Kramer test, and Anderson-Darling test. For Shapiro-Wilk test, null hypothesis is data is normally distributed. An alternative hypothesis is data are not normally distributed. So, we got our p-value 0.1002. That is larger than 0.05. So, we fail to reject H0. Therefore, Shapiro-Wilk suggests data are approximately normal. For Kolmogorov-Shmirnov test, null hypothesis is sample distribution equal to normal distribution. So, alternative hypothesis is sample distribution not equal to normal distribution. So, in here we got p-value as 0.15. That is larger than 0.05. So, we fail to reject H0. That means there is no significant deviation from normality. When it's come to Kramer test, our null hypothesis is data follows a normal distribution, and the alternative hypothesis is data not follow a normal distribution. So we got p-value 0.1393, that is larger than 0.05, our significant value. So we fail to reject H0. Therefore, according to Kramer test, data look normal. Anderson-Darling test. For Anderson-Darling test, our null hypothesis is data follow a normal distribution. So our alternative hypothesis is data does not follow a normal distribution. So we got p-value 0.1251, that is larger than 0.05. So we fail to reject H0. Therefore, Anderson-Darling test also indicates normality. According to these four tests, it seems like our data is normally distributed. According to the histogram and QQ plot, you can also see our data is normally distributed. But sometimes, if your data have outliers, it will give you a not normally distributed data set. I will show you how to correct that.